In preparation for the next couple of weeks, when we'll talk about different classes of organic compounds, today we'll give a little bit of an introduction to each one of those classes, and this last topic in today's lecture will serve as a glossary to the chapters that will follow. So let's talk about classes of organic compounds. The simplest organic compounds are known as hydrocarbons, and as their name implies, they consist only of carbon and hydrogen. And among them, the simplest subclass are molecules known as alkanes, which have only single bonds. The simplest alkane is methane, and methane has the suffix ane, which indicates that the molecule is an alkane. The next member of the class is ethane, followed by propane, followed by butane, and the next couple are simply abbreviated. So C5 is pentane, C6 is hexane, C7 is heptane, C8 is octane, C10 is, C9 is nonane, and C10 is decane. These names will come up not only with alkanes, but also with alkenes and a bunch of other classes, and you have to memorize them. This is a bit unfortunate, but it's absolutely necessary. What makes this memorization easier is that from C5 to C10 they're simply named after corresponding Greek numbers. Some alkanes are cyclic, and that is indicated in their names as a cyclopentane or cyclohexane. Alkanes are distinguished from all other classes of organic compounds because they have no functional groups. And functional groups are part of the molecule which are the most likely to engage into reactions. So alkanes have no distinct reactivity sites. But even despite that fact, other molecules are often treated as derivatives of alkanes, and they're considered derivatives of alkanes in which an alkane hydrogen is replaced by a functional group. So to explain this on an example, if we go from a molecule that looks like this, which is ethane, to a molecule that looks like this, this molecule is named as ethanol because it's ethane in which hydrogen is replaced with an OH group. But this thing that remains constant is the CH3CH2 group, which is named ethyl. And so this YL suffix is what distinguishes these groups, also known as alkyl groups. So we often talk about other compounds substituted with alkyl groups. The notion for an alkyl group is R, which stands for radical, and this could be any given alkyl group. To illustrate this on an example, this compound would be methyl from methane, cyclopentane. This compound, for example, CH3, CH3, would be isopropyl cyclopentane. And in general, compound that looks like this would be simply alkyl cyclopentane. And of course, this applies to cyclohexanes and all sorts of other compounds. The next class of organic compounds, and these are still hydrocarbons, are alkenes. And alkenes have distinguishing feature. They have a CC double bond. In order to denote this in their names, there's the alkene suffix ane is changed into ene, so this will be ethene, also known as ethylene, using the old nomenclature. This compound would be propene, and this compound, for example, will be the so-called 1-butene, since the double bond is between carbons 1 and carbon 2. The alternative is the 2-butene, because here the carbon double bond is between carbons 2 and 3. This is the 2-butene. As we've seen in our topic about isomerism, 2-butene has a cis and trans isomers. Of course, there are things as cycloalkenes, which is cyclopentene, or something a bit more complex, cyclodecene, etc. Keeping in tune with this trend, the hydrocarbons which have triple bonds in them are known as alkynes. And these alkynes are named by using the suffix YNE. This is butane. The simplest one is ethyne, also known as acetylene. Then there's propyne, and so on. Finally, the last class of hydrocarbons are the so-called aromatic hydrocarbons. And these, at least at this point, will appear a little bit strange because their unique feature is that they have this 6-membered ring with 3 alternating double bonds. And so to you this might seem just like a complicated alkene, but it turns out that their properties are different enough to justify separating into the same class. And they also have a completely different set of names. So this molecule is known as benzene. This would be methylbenzene or toluene. And the corresponding alkyl group is not called alkyl anymore. This group is called phenyl group. Of course, we'll talk about aromatic hydrocarbons much later and much more. And so let's just leave it at this for now. And let's move instead to the organic compounds which contain oxygen. So oxygen containing and there are several classes of these compounds. The most common ones are probably alcohols, which have the OH group in them. And they're named as methanol. Now OL is the suffix. Then ethanol, propanol, and so on. The interesting example is a molecule of 2-propanol, basically rubbing alcohol, which has this OH group on the second carbon in the chain. So that's hence the 2. Next class of these molecules are ethers. We'll talk about their nomenclature only briefly, but they basically have a structure which is ROR prime, which means that there are 2 R groups which can but don't have to be the same, attached to the single oxygen in the middle. And these are named simply by looking at the 2 alkyl groups and naming them correspondingly. So this would be diethyl ether because it has 2 ethyl groups attached to a single oxygen, so diethyl ether. This, for example, would be methyl ethyl ether because it has a methyl and an ethyl group. Oh, sorry. The next class of organic compounds are the so-called aldehydes and ketones. They are characterized by having the carbonyl group, so the doubly bonded oxygen and carbon. Aldehydes have a general structure which has a hydrogen here, while ketones simply have 2 alkyl groups, which again can be different or similar, attached to a carbonyl group. They are very polar molecules, kind of like alcohols, because they have this very polarized bond and hydrogen bond to water, so they're very soluble in water. And their corresponding suffixes are Al, so ethanol for aldehydes, and ONE, such as propanone for ketones. This molecule is also known as acetone, much more common. Okay. Finally, we will briefly mention another class of oxygen-containing compounds, and these are the carboxylic acids and their derivatives. Carboxylic acid has a general structure which is RCOOH, and they're acidic because they can react with water to give H3O+, and the resonance stabilized anion, which we talked about already, which makes them acidic because stability of anion helps always. They're named as a corresponding ethanoic acid, for example. Although this acid is also known as, by much more common name, acetic acid. And they're of course very strongly polar, they're soluble in water because they're dissociated partially, so the water can solubilize their anions. And carboxylic acids are also the parent compounds of a whole class of carboxylic acid derivatives, which I will only briefly outline here. But those that have another R group here are known as esters. Then there are things like acyl chlorides, I might need to go to the next page here. And then there are compounds which look sort of like this, and are called acid anhydrides. And finally, the compounds exemplified by this structure. And I'm intentionally using different representations of similar molecules to make you practice this. And these are known as amines. What is common to all of them is that they have this group, which is CH3CO, which is known as acyl group, just substituted with different functional groups. Finally, we will conclude this little discussion by talking about the last class of compounds, the nitrogen-containing compounds. We will probably encounter these compounds again only in the second half of this course, but it's important now to have a comprehensive picture. And the most common of them, common class of them, these compounds are amines, which have NH2 group in them. And they act as bases because they have the free electron pair on nitrogen. So they can react with water and give these alkyl ammonium salts. And the corresponding nitroamides. They're named simply by appending the name of the corresponding alkyl group, such as methyl, in front of the word amine. So this will be methylamine. This, for example, could be methylethylamine. And so forth. Many of the amines are occurring in nature. This compound is nothing other than nicotine. So it's a naturally occurring amine, which is also known as alkaloid. As I mentioned already, and this is a bit of an overlap with oxygen-containing compounds, compounds known as amides, so they differ in only one letter, but an important one, have the C double bond O NH2 group, and these are characterized by the fact that they are not basic, so if we not very basic at all. So if we look at a typical amide, then we can imagine resonance structure with this double pair electron pair of nitrogen moves back, and this goes to oxygen, which now leads to a resonance structure where this nitrogen has positive charge on it already, and hence this nitrogen is not basic. Furthermore, it's a little bit even acidic because once it loses this proton, it gives stabilized anions. And the final class of nitrogen-containing compounds, and again about these we'll talk only several months from now, are so-called nitriles, which are characterized by the presence of the cyano group. The cyano group, one of the very common solvents that we use in labs is known as acetonitrile, and this is how we name these things. This will be another example, the propionitrile. So we'll finish our discussion here, and by completing this lecture, we sort of completed our introduction into organic chemistry. We talked about the concepts of structure, concepts of acidity, about various ways of representing the molecules. We talked about polarity in molecules, about properties that come from polarity. And finally, we finished with a brief introduction to every single class of molecules we'll talk about later on. Next week, and next lecture actually, we will start already talking about the first class of organic compounds, and these are the simplest ones, alkanes, so a class of hydrocarbons which only contain single bonds. Until then, thank you very much.